Hello. We are from Group 7.
Our members consist of Adil Muhammad Fauzil Mutakin, Rasad Sefa Muhammad Nabiha, Gilang Ramadan, Syekh Maulana Syafei, Sehabuddin Ahmed Al-Ashhab.
We'll have a presentation about linear equation. First off, what is a linear equation? In general, linear equation is an algebraic question where each term has an exponent of 1. And when an equation is graphed, it always results as a straight line. This is the reason why it is named as a linear equation.
Or in short, linear equation is an equation that has the highest degree of 1. Which means that no variable in a linear equation has a variable whose exponent is more than 1. And the equations always form a straight line. It involves only a constant and a first-order term, where m is the slope and b is the y-intercept. Occasionally, the equation above is called a linear of two variables where y and x are variables. To know the linear equation better, we could use some examples to identify if it is a linear equation or not.
With what we know, we can conclude that this equation is indeed linear. The reason being, it has two variables x and y, as well as the slope and y-intercept. Another example would be this. Unlike the previous equation, this equation falls under the nonlinear category. The reason why is simple. It has both variable as well as slope and y-intercept. But the x variable has the power of 2. Therefore it cannot classify as a linear equation. This example also falls under the nonlinear equations. Unlike previous equation, this one is a nonlinear equation because of the variable y. In linear equations, variable cannot have a power of or square root. Therefore it is a nonlinear equation. So then, what is the linear equation formula? The formula of linear equation can be done in very different ways. For example, a linear equation can be expressed in the standard form, the slope-intercept form, or the point-slope form.
Now, let's talk about the forms of linear equation. First, is the standard form of linear equation. There are two ways a standard form can be written. This is the first way. It's written in a way where a and b are a real number, while there's x as the only variable. This is called the single variable equation. Whereas in another way, the two-variable equation, it would be written a little bit differently. This is our prime example. In this equation, the variable a and b acts as a coefficient of x and y respectively. Meanwhile x and y are the variables, as well as c as a constant. In this very short section of the presentation, let us talk about the graph of a linear equation. In one-variable forms, the graph tend to form a vertical line that is parallel to the y-axis, and vice versa, whereas the graph of a linear equation in two variables x and y forms a straight line, like this. In this chapter, we will be explaining how to solve various questions of linear equation. The easiest equation to solve is single variable equation. Just like the previous chapters have covered, single variable equation is an equation consisting of two real numbers and a variable. There is only one solution to this equation. The most simple way to deal with this equation is to separate the variable and bring it to one side, whereas the constants will be combined and brought to a side opposing the variable to get the desired value. Let's apply that to this example. By using what we know, we should bring the constants to the right-hand side, and we should keep the variable on the left hand as such. Then combine the constant and make it look like this. Separate the constant, bind it with x, and move it to the right hand. Because the constant came from the variable, it should look like this. Finally, divide both constant and then you'll get the x value. On the topic of single variable, what if the question would be like this? The solution to this is also still very simple. First, what you need to do is to transfer 3x to the left-hand side. By doing this, it will turn it into a negative variable. At the same time, transfer negative 19 to the right-hand side. This time negative 19 will become positive. Then combine both the variables on the left-hand side as well as the constant on the right-hand side. Because both sides are the multiplication of 3, we should be able to divide both sides by 3. By doing so, we will get the value of x, which is 3. Now let's try something a little more complicated. Let's try this example right here. This may look complicated, but it is also very easy to solve. Unlike the other questions, this one question is an addition-division question. So the first step you need to do is to see a common multiplication of this question, which is 3 and 2 respectively. After it looks like this, you should combine the variable constant. So now you have 5x divided by 6. What you should do after is to transfer 6 to the right-hand side and put x and negative 7 into a bracket. To break the bracket, multiply x and negative 7 by 6. Only then you can transfer 6x into the left-hand side. After you transfer it, you should be able to do the small equation and are left with negative x and negative 42. Because both sides are negative, you can remove them, making them positive. So now you have positive. Let's try another question. This one might seem complicated, but it follows a similar step as the last two questions. First, cross-multiply the two divisions so you are able to remove the bracket. How to break it is just like last time, by multiplying the equation inside with the number outside. Now you will have two equations on the left and right-hand side. Just like the others, we will transfer negative 2 to the left-hand side, changing it to a positive, and does the same to 9. Transferring it to the right-hand side, changing it to a negative. All we need to do now is to add them together. And finally divide both sides with 5 so we can get the x value, making the end value 1 divided by 5. Now is our last sample of one-variable equation solutions. This one question is special. Unlike the rest, it is a division of two bracket equations. At first glance, it might look much more complicated than the last few questions. But I can assure you this is just as simple as the others. First, what you need to do is to transfer x plus 4 to the right-hand side. So now you should have both equations split on two different sides. Since the x plus 4 equation are multiplied by 1, it will remain the same. After that, the steps forward should be the same as the rest. Transfer positive x to the left-hand side, and it changed it to negative x. Do the same for positive 5, making it negative 5. After that you should add them together, making the equation now be x equals negative 1. So now you have negative 1 as the value of x. Then what about the two-variable equation? Let's try to do this example of the two-variable equation. Because there is two different equations, we should isolate the first equation for x value. By doing so, the first equation will be changed slightly. And with that we should substitute it to the second equation. Now the equation should look like this. Proceed by multiplying 2 with y and 12. Just like before, move the only constant to the right-hand side and combine them. And finally separate the constant tied to the x and divide them. Now you have the y value. You must be wondering, then how do we get the x value? After you obtain the y value, now you must substitute the y value into the isolated x equation. Then it should be like this. It is addition and not a multiplication. You should first multiply 12 by 3. Once you have it, proceed to add negative 2 and 36 together. And that is how you get the x value. So, we have reached the end of our presentation. And now to our conclusion. This video is made for the purpose of introducing you to linear equations and matrices, as well as the ability to understand the basics of using matrices to represent systems of linear equation. You also should be able to find that your skills in producing convincing arguments and problem solving are improving. You should now be able to use the method of Gauss-Jordan elimination to find the solutions of systems of simultaneous linear equations. Solve a system of linear equations by a row reducing its augmented form. Perform the matrix operations of addition, multiplication, and transposition, and express a system of simultaneous linear equations in matrix form. Evaluate the determinant of a 2 by 2 or 3 by 3 matrix, and use the determinant to determine whether or not a given 2 by 2 matrix is invertible.